following is a production of the Metro Applied Research Club and the Department of Computer Information Systems at the Metropolitan State University of Denver, with special thanks to our corporate sponsor, Nebraska Aluminum Castings, quality, custom aluminum die casting in Hastings, Nebraska. Welcome to the lecture Association Rules, the Basics. The goals of this lecture are to introduce the student to key concepts of association rules, including what association rules are, how they can be applied, and how they can be interpreted. To introduce the student to important terms and definitions central to association rules, and to demonstrate how association rules can be created and assessed using a simple data set. Some of the key words and terms you will want to pay special attention to include association rules, support, confidence, if-then, antecedent, consequent, and item set. Today we're going to be exploring association rules, and to follow along with me, you're probably going to want to have two files. The first one is an Excel file called Credit Risk Association 2 Workbook Final. That's an Excel file, and you should have that available to you. If nothing else, you can go to www.joehasley.com. The other file that you might want to be able to find is a lecture from the MIT website. It's called Discovering Association Rules in Transaction Databases. To explore association rules, we're going to be looking at a relatively simple problem. The data in the file Credit Risk Association 2 Workbook Final basically allows us to determine credit standing. Credit standing is going to be our dependent variable. And then we'll be looking at several independent variables and trying to figure out, can we predict the outcome of the dependent variable based on the independent variable values. So for example, we're given an independent variable of checking account. The data tells us, do they even have a checking account? This person has no checking account. Or no account, this person has no balance. So they have an account, but they have no money in it. These are all relative. We're not given a dollar amount. We're just told relative values. Credit history, basically, are they current on all their bills? Did the bank have to pay something off? Are they behind on it? Those types of things. We're told the purpose of a previous loan, which was for small appliance or furniture, maybe a new car. This tells us, as opposed to a checking account, we're asked to look at a savings account and the amount that they have into it. They may have no account. Their employment, how long have they been at their job, their gender, the marital status of the applicant, the housing status of the applicant, what type of job they have, do they have a telephone, are they foreign born, their current age, and ultimately, basically, should we give them a loan or not, credit standing. So again, credit standing is the dependent variable that we're looking at, and we're going to try and predict that based on these independent variables. In the case of this data set, I have 425 instances or examples. And again, our task is to determine some rules based on this data that will help us make good decisions about who to loan money to or not. So let's talk a little bit about association rules. Association rules provide information in the form of if-then statements. These rules are computed from the data and, unlike the if-then rules of logic, association rules are probabilistic in nature. In addition to the antecedent, that's the if part, and the consequent, that's the then part, an association rule has two numbers that express the degree of uncertainty about the rule. What this means is the rules are not hard and fast. Instead of stating a rule such as, it is cloudy, so it will definitely rain today, a probabilistic rule would say, it is cloudy, so it will rain today, is true about 40% of the time, or whatever percent. In association analysis, the antecedent and the consequent are sets of items, called item sets, that are disjoint. That means they do not have any items in common. For example, if we consider marital status, we see that the options are single, divorced, or married. Now, in real life, you could be separated. There could be other options, but in this data set, We have three values, and those values are both mutually exclusive, meaning you can only be in one category, and they are collectively exhaustive, meaning those are all of the possible options for this data set. Let's go ahead and examine a few simple association rules together. For example, a simple association rule would be if a person is single, then they have good credit. Another association rule would be if the person is single, then they have bad credit. And our task is to somehow examine and say, are these good rules or not? Well, when we examine a rule, we'll judge it by two numbers. The first number is called the support for the rule. The support is simply the number of transactions that include all items in the antecedent and consequent parts of the rule. The support is sometimes expressed as a percentage of the total number of records in the database. So for example, I can run a simple Excel formula, a COUNTIF, and I can say, out of my 425 records, tell me how many of them have a marital status that is single. Well, that turned out to be 223 times. That's just of the 425 records, how many of the 425 have a marital status of single? The next thing I want to calculate is, of the individuals with a marital status of single, how many of them have good credit? Well, that's my confidence. Put simply, confidence tells us of the 233 people in our data set with a marital status of single, 130 of them had a marital status of single and also had a credit standing of good. So about 55.8% of the 233 single people ended up also having good credit. Also, you can see that of the 233 single people, 103 of them ended up having bad credit. So about 55% of the single people had good credit, about 44% of the single people had bad credit. Support tells us out of the whole data set, how often does this rule hold true, that single people had good credit or that single people had bad credit. So this says out of the 425 people, about 30% of them were single people with good credit and about 24% of them were single people with bad credit. Let's consider a second rule. Let's consider the rule, if divorced, then credit is good. The confidence for this rule is 0.4166, or roughly 41.6%. And what that says is, if you are divorced, then there's a 41.6% chance that your credit standing is good. On the flip side, if you're divorced, then the probability that your credit standing is bad is 0.583, or about 58.3% of the divorced people had bad credit. Now, it's worth noting, if someone is married, I can't really tell much about them. They have almost a 50-50 chance of being a good or bad credit. Finding out that someone is married doesn't give me much of a statistical advantage over just flipping a coin. That is to say, if you had access to this information and someone else didn't, and that someone offered you a bet of, I'll bet you $10 that a married person is a bad bet, the information is not giving you much of an advantage. Compare this to the information that a person is divorced. If you had access to this information and someone else did not, and that someone offered you a bet, I'll bet you $10 that a divorced person is a good bet, you would know that if you take the bet, so that you're betting that a divorced person is a bad bet, then the odds are significantly in your favor. This is a clear way to quantify the information utility or information value of the association rule. This is a direct application of the value of perfect information that you learn about in your management science class. This marks the end of part 1. Please join us in part 2 as we do another example and wrap up the lecture.